Today's lesson is on property of kites. So we're going to look down the branch of property of kites that has 0 parallel sides. There are 4 characteristics on our tree diagram for that. So first of all, we have no parallel sides. We have 2 sets of adjacent congruent sides. We have diagonals that are perpendicular. And we have 1 set of opposite angles that are congruent. So if we look at our presentation here, the first property we're looking at is that we have 2 sets of congruent adjacent sides, which means these 2 sides are congruent here. I'm going to name that AB. And AD. All right. So AB is congruent to AD. BC is congruent to DC. Now, if I draw in a diagonal right here from B to D, what that does is that breaks that kite up into 2 isosceles triangles. Being that you have isosceles triangles, that tells you have base angles that are congruent. So I'm going to number these angles 1, 2, 3, and 4. Angle 1 is congruent to angle 3 because of the base angles for that left isosceles triangle. And angle 2 is congruent to angle 4 because of the base angles of the right isosceles triangle. Here's a problem that uses the idea that you have 2 sets of adjacent congruent sides. We can see here that AB has an algebraic expression that represents the value that is 2x plus 1. That is going to be the same as AD, so we can repeat that. We had 2x plus 1 there. DC has an algebraic expression of 3x minus 6, so BC will also have an algebraic expression of 3x minus 6. Now we're going to go ahead and write a formula for this. We got 2 sides that are 2x plus 1 and 2 sides that are 3x minus 6. So we're able to take those and add them up to equal 115. We're going to use our distributive property. That gives us 4x plus 2 plus 6x minus 12 equals 115. We'll go ahead and combine our like terms. And then as we go about and solve this, we would end up getting an x value of 12.5. In our next characteristic of a kite, we have 1 pair of opposite angles that are congruent. As we talked about in the previous problem, if we draw in a diagonal right there, we end up with 2 sets of isosceles right triangles. And in those isosceles right triangles, we have base angles that are equal right there. And we have 2 base angles that are equal right there. Now, if we got those 2 sets of congruent angles, we can tell that these larger angles, angle B and angle D, the large angles, are also going to be congruent. Those two are the pair of opposite angles that are congruent. The other 2 angles are not necessarily going to be congruent. If they were congruent, that would give us 2 sets of opposite angles which are congruent, forcing it to be a parallelogram. So here we're going to use that property. We need to find the value of x, and we're working with the angles. We have to remember that the angles of a quadrilateral always add up to 360 degrees. So what we would do here is we would start off with 80 plus 70 plus x plus our other angle has to equal 360 degrees. These are our two congruent angles here, so if one of them is x, the other one has to be x. And that's what completes our equation. Now we got all four angles adding to 360. That would give us 150 plus 2x equals 360. 2x would equal 210. And x would equal 105. Our next property, the one I have listed here in this video, is not one that I originally put on the tree diagram, but holds true all the time, is that one of the diagonals is always bisected by the other diagonal. Now, there is no rhyme or reason to this as far as the longer one bisecting the shorter one or the shorter one bisecting the longer one. It can really happen either way. But what does hold true here is when you look at the two isosceles triangles, it is the base of those two isosceles triangles that is always a diagonal that is cut in half. So we have isosceles triangles here, ABD and BCD. They both have base BD. That is the diagonal that is cut in half or bisected. Here's a problem that uses that characteristic. You can see here you have these two algebraic expressions for the diagonal that is bisected. So all you're simply going to do is make those equal to each other and solve for x, and then answer your question for the length of BD. So 4x minus 8 equals 2x plus 6. Then we can go ahead and solve this. Two x would equal 14. X would equal 7. We come over here and plug our 7 in here. 2 times 7 plus 6, that'd be 14 plus 6 is 20. We know that this bottom one should also be 20, but we can plug it in anyway. So 4 times 7 would be 28 minus 8 is 20. And then if we add those up, our answer to our question, how long is BD? BD is 40. Our next characteristic is that the diagonals are perpendicular to each other. The best explanation of why this happens is, again, if we look at those two isosceles triangles, you can notice that the one diagonal that I have as the long diagonal, the one that's not the bases of the isosceles triangles, is always, in a kite situation, going to be the altitude of those two triangles. So being an altitude, you end up with a right angle to the base. And if you have one right angle there, you have four right angles. And what that opens up the chance to work with right triangles. And a squared plus b squared equals c squared, or Pythagorean theorem, comes into play on these problems. But for example, this one here, we want to find the perimeter of triangle AB or kite ABCD. To do that, we need to find AB, BC, CD, and AD, those lengths. So we need to use Pythagorean theorem on these. So the Pythagorean theorem here So that gives us 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared, giving us a c value of square root 40. If that's square root of 40 there, that means AD is also square root of 40. And then we can go ahead and reason out BC by using Pythagorean theorem here with the 6 and the 10. That would be 6 squared is 36, 10 squared is 100. (100) plus 36 is square root 136. And we can copy that down to DC because those two sides are also congruent. So now if we add all those up, you can see I already did that here on my calculator. We end up with a value of approximately 36.